Okay, 9.2 is the second derivative of parametric equations. So for the second derivative, we have another formula to follow, and that is d squared y over dx squared is equal to d dx of dy dx, which is equal to d dt dy dx divided by dx dt. Okay, all this is saying is that we need to take the derivative of dy dx and then divide by the derivative x of t. So that's what we're going to do, which means in order to find the second derivative, we're going to have to find the first derivative before we continue. So number 1 gives us x of t and y of t. So first we find dy dx, which means we do the derivative of y first. So if I was to distribute this 1/2, I would have 1/2 t squared, so the derivative of that would be t, divided by the derivative of the square root of t, which is the same as t to the 1/2 power. So this would be 1/2 t to the 1/2. Oh, sorry, negative 1/2. Can't forget the negative. Okay, so if I was to simplify this, I could get rid of the 1/2 on the denominator, move it to the numerator by taking the reciprocal, so I have 2. And then I have t times t to the 1/2, which is 2 times t to the 3/2. Okay, so that's my first derivative. Then my second derivative is going to be the derivative of my first, so the derivative of 2t to the 3/2, which is 3t to the 1/2, divided by, again, the derivative of x, which we already found is 1/2 t to the negative 1/2. Okay, from here I would simplify, so I'd move the 1/2 to the numerator by multiplying by the reciprocal, so 3 times 2 is 6. So I have 6 times t to the 1/2 times t to the 1/2 if I bring the t to the negative 1/2 to the top, which is the same as saying 6 times t to the 1/2 plus 1/2, which is just going to be 6t. That is my answer. Okay, next, number 2. I have to find dy dx first, so I would take the derivative of y, which is 4 cosine t, and divide it by the derivative of x, which is negative 3 sine t. This can simplify to negative 4/3, so I take out the constants to make a fraction, and cosine divided by sine is cotangent t. So then if I'm taking the second derivative, I first have to take the derivative of negative 4/3 cotangent, which is going to be 4/3 cosecant squared, because the derivative of cotangent is negative cosecant squared. Negative and a negative is a positive. 4/3 comes down. And then divided by the derivative of x, so negative 3 sine t. Well, I can combine that negative 3 on the bottom with the denominator of the 4/3, and I get negative 4/9. And then I can rewrite this as cosecant squared t times 1 over sine t. Well, 1 over sine t is cosecant t, so this is negative 4/9 cosecant squared t times cosecant t, which is just negative 4/9 cosecant cubed t. And that is my answer. Okay, last problem, number 3, says at t equals 1, find the concavity of the graph defined by the parametric equations x and y. Okay, so since we're talking about concavity here, we need to recall that in order to determine concavity, we need to find the second derivative. So in order to do that, first I'm going to find the first derivative. So dy dx is equal to the derivative of y, so that's 4t cubed plus 1. Okay, divided by the derivative of x, so 3t squared. I can simplify this by moving it into 2 fractions, so this could be 4t cubed over 3t squared plus 1 over 3t cubed, which simplifies to 4/3 t plus 1/3 t to the negative 2. Okay, again, the reason why I'm simplifying is because it's a lot easier to take the derivative of this than it is to take the derivative of this. Okay, doesn't mean you can't, but you'd have to use the quotient rule, and that's just more steps and more risk for making mistakes. So now I'm going to find the second derivative. And so I have 4/3 minus 2/3 t to the negative 3 over the derivative of x, which is 3t squared. I'm going to solve that when t is equal to 1, and I'm trying to see if my second derivative is positive or negative, and that's going to help me determine if it's concave up or concave down. So I have 4/3 minus 2/3 times 1 to the negative 3 over 3 times 1 squared. This is equal to 4/3 minus 2/3 over 3, which is 2/3 times 1/3, which is 2/9. And since 2/9 is greater than 0, we would say that this is concave up at t equals 1. And that would be our answer.